All right, we are live. Welcome to Science Never Stops with the U.S. Space and Rocket Center. My name is David Weigel, and I am the Intuitive Planetarium Director. And today I'll be taking you on a quick exploration of Mars using the software OpenSpace, which is free and available to you at openspaceproject.com. So while we're waiting to get some more folks in here, where is everyone chiming in from or tuning in from this evening? One person's from So Excited, fantastic. Pacific Northwest, very cool, very cool. That's not close to here at all, but a beautiful area. Also, while we get rolling, I have a quick question to ask you. Kentucky, very cool. Multiple Kentuckys, Georgia. People who work for me, fantastic. Wisconsin, Birmingham. Hello to John and Karen, Joel, Shannon, Jacinda, Kayla, Noel. I may be missing some people. Thank you for joining in this evening. If you missed my earlier welcome, this is Science Never Stops with the U.S. Space and Rocket Center, and my name is David Weigel, and I am going to turn off my phone so it doesn't ding. I'm also the Planetarium Director at the Intuitive Planetarium, and right now we are cruising over Mars. And the question is, I've just put up a poll for you, I don't know how you see that, but somewhere you can see a poll hopefully, and the question is, where are we currently flying? As people race to get some results. I was a bit snarky, it seems. And you're on board with it. Fantastic. So yes, I agree with you that we are social distancing to the extreme. And there is another object, not a person perhaps, but something at least slightly intelligent, which is going to be visiting this place very soon, in the next little while, hopefully launching this year, and that is the newly named Perseverance rover. This is Jezero Crater right in here, so I just gave the answer, so hopefully we'll watch those ding up really quickly. For those of you who answered Ulympus Mons, this Mons means mountain, and there's not much mountain going on in here, so it's not that, sorry. For those of you who answered Valles Marineris, that is a huge canyon that we'll be exploring today. That's not this either, and I guess you really are right if you said social distancing to the extreme, so I'll give you your results right now. But we're cruising over Jezero Crater in here, and I want to highlight that everything that you're looking at in this video right now, or in this live stream, is going to be all real data. These are all real pictures of Mars that are taken from various spacecraft, and this in particular, this imagery that you're seeing is incredibly high resolution. It's about 25 centimeters per pixel, so that's about 10 inches. So what that means is that if you have something about the size of a football, an American football, then if you see a rock like that big on Mars, that's something that we can pick up in this imagery, which is pretty fantastic. So further, as we're looking down at this imagery, and hopefully you can all see my mouse down here, I'm going to keep the sort of context bar open for you so that you can see what I'm doing, so that in the future you can go back to this video, or you can follow along now if you like, if you have the software. And this will give you a little bit of an understanding of how to use OpenSpace. Which again can be found at openspaceproject.com. So as we're cruising over Jezero Crater in here, you may notice that this looks like sort of desert-like, and I don't disagree with you there. I'm going to bring our altitude up a little bit, and I'm doing that by right-clicking on the screen with my physical mouse and dragging down, so right-clicking and dragging down. And then I can sort of change where I'm cruising by left-clicking and moving that around and right now I have friction turned off, which I can use the F key on the keyboard to turn that off. So if I hit that, for example, our beautiful progress will stop. If I toggle it again and start clicking, then we'll start moving in the direction of my left click and drag, and at a speed depending on how fast we go. So now you know all of my tricks, and you can see if I'm flying very well or not. So what this may look like to you, especially if we start to move up in altitude and a little bit quickly, you can start to see some more imagery tile in here in the background. Especially in this area right in here, this looks a lot like an ancient river delta, because perhaps it is. And so this is really the motivation for us to visit a place like Jezero Crater, is to follow the water and try to figure out, what Mars used to be like, where there was water on Mars, when there was water on Mars, which is even the bigger question, and how that shaped the Mars we know today, and further, how that shaped the Mars that we do not know from a long time ago. So I'm going to hold down Control and left click, the Control key and left click. When I do that, I can change my camera orientation and show you some what I think is certainly incredible. I'm going to go down in elevation as well, because this is very, very pretty. And you can see those features really nicely in here. Now, what I want to do today is give you a brief overview of, first off, just how pretty Mars is, but some sort of quick Martian geology, which would be, I guess, areology, areography, that sort of thing. So I'm actually going to zoom away and do so rather quickly. We're going to go straight up here. And you can see us leaving the Martian atmosphere behind. I'm going to turn our view down, and you'll notice a little bit of a patchwork Mars, maybe not as polished as you expected to see. And again, that's because everything that you're looking at in here is all real data. And so there are places of Mars that we haven't surveyed with as high a resolution as others. So we have surveyed 100% of Mars, but we have not done so in sort of increasingly excellent resolution. So you can see in here, this is a place where we have some missing data. So I want to pull all of us away a little bit more, and let me bring us to north is more or less up here. So again, Jezero Crater in here. And I'm going to change what imagery we have shown here. So we can change our imagery by going into the scene and figure out what different things we have pulled up. So I'm going to clean this Mars up a little bit for you. And this is something that you're maybe familiar with, or perhaps even more so, this color right in here, a little bit redder perhaps, if that will tile in. I take it back. I won't do, oh, there we go. Okay, cool. My internet's catching up with me. Everyone following along so far? Make sense? So we are loading in data in real time, so that's why it takes a few minutes sometimes. And I'm going to, actually, let me do this for you. Since this one's taking a second, let me pull up a false color look at Mars and give you a sense of the very, very different changes in elevation that we see in Mars, which is really, really dramatic. So there's this dichotomy with Mars where the sort of northern third of the planet is very, very low in elevation. It's only about, it's maybe 5.5 kilometers on average lower than the rest of the planet. So quite dramatic. It's also very, very minimally cratered. So in this color scheme in here, purples and dark blues are going to be very, very low elevations. Again, this could be super, super deep, and in the case of the Hellas Impact Basin in here. This one is very, very deep, maybe 7.5 kilometers deep. So very, very large impact in here. This is the 3rd or 4th largest crater on Mars. Greens, light blues into greens are going to be sort of average Mars, so sea level, so to speak, except that Mars doesn't currently have oceans. So you're dealing with not actually sea level, but sort of an agreed upon datum, as we say. So that's sort of the mean radius of Mars. That's agreed upon. And then yellows into reds into whites are going to be even higher in elevation. So we're going to continue our view around here. We're actually going to follow the sun. We're going to go forward in time a little bit. I take that back. We're going to go back in time a little bit. We're going to follow the sun backwards. And cruise along here. You can see high elevations in the south, low elevations in the north. Keep cruising further. And come up on some things that are very, very prominent, very, very bright indeed. And here we have 4 things that should stand out really, really well. We have this and these 3 right in here. And this right in here is the largest volcano in our solar system, 2nd tallest mountain, but largest volcano, tallest volcano in our solar system. And this is Olympus Mons. So Olympus Mons is almost 3 times taller than Mount Everest, and it's about 26 kilometers above the surrounding plains in here. So this is a very old piece of Mars. And the Tharsis Bulge, which is this bit right in here, with these 3 volcanoes in here, we have Ascraeus Mons, Pavonis Mons, and Arsia Mons in here. So these are the next 3 largest volcanoes in the solar system. So the 4 largest volcanoes in the solar system are all located right in here. And this whole area that you can see is incredibly, incredibly high. Again, that's called the Tharsis Bulge, and it's about the mass of the dwarf planet Ceres, which resides in the asteroid belt. So Ceres isn't particularly big, but that's an incredible amount of mass on this one spot of the planet. So what's really interesting about this, and you can see this giant crack next to it, which is called Valles Marineris, a huge canyon. What's really interesting about this is that in the formation of Mars, you had this enormous buildup of material in here, in the Tharsis Bulge, so much so that it was pushing down really, really hard on the crust. Lots and lots of mass means lots and lots of weight, even in a lower gravity Mars. And this basically removed it. The crust and mantle were no longer in equilibrium, called isostasy. And so basically have this rifting open up with Valles Marineris, or at least one good idea. And perhaps some other contributing factors, but this cracks open this enormous canyon, which is then further sort of eroded out by liquid water and also wind erosion. So you can see in here, very, very high, very, very deep. So let's go explore that in great detail. So I'm going to bring up higher resolution. Right now we're looking at about 230 meters per pixel in resolution, which isn't very good. As we zoom in, I'm going to turn on another data set, which jumps us up to about 6 meters per pixel in resolution. That's CTX, which is from the context camera on board the Mars Reconnaissance Orbiter. And then as we get even closer, I'm going to bring up the high-rise data set from the same Mars Reconnaissance Orbiter, but it's a higher resolution camera and very, very pretty. Okay, here we go. Let's get in a little bit closer. So we're going to sort of cruise into Valles Marineris proper in here. I'm going to bring our time back just a little bit so we get a little bit more daytime in here. And we're actually going to take a quick detour, let's see, and trend our way north. And this right in here, this is sort of the western portion of Chasma. So Valles Marineris is this huge complex canyon region, but it has very, very many different sort of smaller canyons within it, sort of fingers within it, and this one in particular is called Chasma. And you'll notice this resolution is pretty impressive as we start to zoom in and as things render out. Let's get us a little bit closer. Bring up our field of view in here. We have these really steep canyon sides in here, which are likely the result of sort of further collapse after the initial rifting, if that is indeed what happened. As we drop down even further, we can start to see really, really fine scale features that indicate that while this likely did have water in some capacity at some point, though perhaps sort of in episodes where you have water sort of fill in and then flood its way out, a lot of this erosion is actually probably due to the wind in here. So as we get a little bit closer, this will become a little bit more clear. And we're looking at features in here that are in the several hundreds of kilometers in size, several hundreds of meters in size, some up to, maybe 1 or 2 or 3 kilometers in a rare case, but mostly in the order of hundreds of meters in size as we zoom in closer and closer. If everything looks sort of yellowish or so, almost yellowish reddish, that is due to atmospheric scattering, and that is a pretty true color Mars that we're seeing in here. Now, this is a good time for me, especially as this starts to render and my internet catches up. Clearly, I'm here at home in this nice room that's awaiting my soon-to-be-born second child that has no decorations on the wall, which our social team reminded me is extremely boring. Very cool. Oh, I see now that, side note, I was not following along with all of your comments, and I apologize. Let's see. When do you think there was water on Mars? 5 minutes ago. Great question. A very long time ago. When that was? Very, very much up for debate. Very much one of the biggest questions that we have unanswered about Mars, and that's really why we're sending spacecraft there as much as we possibly can, and to places that are intentionally very ideal for studying old water locations, ancient lake beds, for example, like Gale Crater, where Curiosity is currently exploring, that sort of thing. So when possibly billions of years ago, in the 2 to 3 billion years ago, maybe more recently, but very hard to say, and I certainly don't know. Are there plans to map other planets? Absolutely. We are mapping other planets all the time. In particular, something that is not a planet that was just released, though, is the asteroid called Bennu, which is being explored by OSIRIS-REx, and it's actually the highest resolution mapped world besides the Earth at, I think, 5 centimeters per pixel in resolution, compared to 25 centimeters per pixel in a resolution that you're seeing in here right now. So that was released a few days ago. It's a sort of diamond-shaped asteroid, about 900 meters across, something like that, so quite small, and OSIRIS-REx is actually going to sort of high-five the surface and take a sample and bring it back, which is really exciting. Top fan Jimbo says, "This is so awesome." I completely agree. A good time for me to point out that, and remind you again, that this is all real imagery. This is taken from the HiRISE camera on board the Mars Reconnaissance Orbiter, and our resolution is about 25 centimeters per pixel. and in terms of the imagery, and then the elevation mapping is about 1 meter per pixel in resolution. So we're able to get this, this elevation mapping because we're taking stereo pair images. I say we, the spacecraft. So it takes a picture from one angle of a space and then looks at it from a slightly different angle in the same space and takes a picture of the same space, and we can, based on this, get an understanding of just how these things are a little bit different, and can compute elevations based on that. And this is the result of that visualization, which is amazing. The question is, what is the biggest crater on Mars? And I don't know, actually. That's a great question for Google. Sorry, maybe social team can help me out there, not sure. Also, so a question is, how long did it take to map the planet? And that's sort of an ongoing process, of course. So if you think of the Earth, we've mapped the Earth, but we certainly, if you go to Google Maps, for example, and you go to some regions, like your house, it's probably great, and other places, it's probably not as great. So we have mapped the entire Earth, but not to extremely high resolutions everywhere. And the same corresponds to pretty much every single planet. So the high-rise camera maybe has, at this resolution that you're seeing here, we're looking at maybe, I don't know, 27% of Mars. The context camera, which is about 6 meters per pixel in resolution, that's looking at almost 100%, maybe 97% of the, maybe I'm lying to you, something along those lines. It's quite good. And then we do have 100% coverage at lower resolutions. And the poles, our imagery at the poles in places leaves a bit to be desired. So it's still happening, but we are continuing to do it. As we come to the end of this really high-res strip right in here, and you're seeing these towering mountains at the edge of the canyon, the edge of Chasma in here, you'll see that there's some disagreement in here. And again, we're using real data, and the way all of this is sort of put together is that the elevation map for this strip is localized, and it doesn't quite agree with the rest of this. So actually, let me do this for you to prove a point. Let me turn off my beautiful flying here and zoom back for you a little bit. And you can see all of these crazy changes in elevation. It's really beautiful. Let me highlight what happens if we get rid of this height map and just keep the base height map. Spoiler alert, we may go into the ground or above it a lot. So that is really not very exciting, right? If you look at this, the imagery is still the same resolution, but we're not getting that same pop. And again, this is without exaggeration. So if I bring that back on, you can see just how amazing this terrain is, and really, really pretty. All very cool. Okay, so the question is, where is the rover? There are different rovers. There are a few of them. Curiosity, which is the only active one on Mars at the moment, is in Gale Crater. And Perseverance, which will launch hopefully later this year, is going to be situated in Jezero Crater, which we visited at the beginning of this video, and you can go view it as if you either rewind or watch this video again. Okay, so side note, actually, while we're just promoting Space Camp and the U.S. Space and Rocket Center, the young man who named Perseverance is not an Alabama native, but he did attend Space Camp, and that's where presumably he became very passionate about space enough to name Perseverance. So you too could go to Space Camp, and you can contact someone, not me, about that, and they can get you set up, and it's lots of fun. You can go to the Planetarium while you're there. It's amazing. Wow, cool promotion. Okay, so let me back away. I wasn't even looking at the screen. We're still in Valles Marineris, and I want to show you another place, simply just to highlight some of the wow that we're working with. So let me zoom away a little bit to give you a sense of scale. Let me bring this back into view. For those of you who like to look at different worlds and try to find things on them. You can orient yourself on Mars using a couple things. You can use Olympus Mons in here and the Tharsis Bulge sort of volcanoes in here, Tharsis Montes in here. And if they have this sort of triangle where Olympus Mons is in the top left, then north is up. If you're not looking at those and you're instead looking at Valles Marineris, and let me make this a little bit more obvious, this almost looks sort of like a gun with a scope, perhaps. And as one of my employees put it, maybe that's firing some smoke or something, or perhaps a really long, thin teapot. That's a worse idea. But either way, if the scope is on the top and the smoke is sort of moving up, then north is up in here. Bring this back on. So to give you a sense of scale, this Valles Marineris is really, really deep. It's really, really long. It's about 5 times the depth of the Grand Canyon, so quite deep. And it's about as long as the United States is wide. So tremendously big place in here, deep place in here. Let's go back in time just a little bit to get our daylight a little bit more ideal. You can turn off daylight and shading and those sorts of things if you so desire, but I think it looks very pretty, so we'll just play with the time a little bit. This in here is called Ganges Chasma, and I really like Ganges Chasma. This is maybe the first thing I saw when I first used OpenSpace, and I was just very impressed. So let's cruise along here, and I'm actually going to bring us all the way about so that we're sort of facing south. And as we start to cruise in here, again, we'll have to wait for resolution to sort of tile in. But this in particular right in here is extremely impressive to me. So I like to climb a lot, which is a little bit tough in this whole social distancing thing because all the climbing places are closed, and understandably so. So I have to climb at home. But I really like to climb, and one of my fondest memories is going to the Grand Teton National Park with friends and traveling there, hiking there, climbing there. And it's just a really beautiful place where you have this very pleasant plain, and then you have these very, very sharp, jagged mountains that poke up. And that's basically what we're seeing here on Mars. Sort of the Martian version of that in Ganges Chasma. So again, if we didn't have these localized elevation maps, we would see something that's high resolution but fairly unimpressive, just a sort of like lump on the surface. These mud deposits are, I don't think, very well understood in that they're possibly the result of wind erosion and wind deposition. So wind sort of eroding material away and then sort of plopping it down in here. So let's sit here for a moment, get a little bit closer, and wait for all of this to tile in its full glory. And while we do that, one last side note here is that this is, again, free software and something that you can download on your own at openspaceproject.com. I will say, though, that you do need a fairly reasonable computer, especially graphics card-wise, in order to handle this. This is not something that could be run on your extremely basic laptop or something like that, or a tablet. You definitely need at least a decent graphics card in order to get you rolling, and a better one to get you rolling smoothly. So back to Ganges Chasma, we can see some really impressive mountain peaks here. And again, this is without any exaggeration at all, and all of this imagery is real. This is correct star field as well at this time of day and in this location on Mars, which at this point we're at yesterday. But we could be at now if you want it to be. but then we'd be in the dark. So, or sort of in the dark. All right, so I think at this point, let me bring you back up and give you one last look at Mars before we conclude our presentation here. And let me give you an idea of where we started, for those of you who have been with me through the entire presentation. Thank you for that. Oh my, I hit a button that I've never hit before. If you hit G, it turns off the atmosphere and atmospheric effects, so good to know. Now you know too. So let me bring us around so that north is once again up. And let me bring us over here to the east, back us away just a little bit, and go back in time a little bit more. And point out, okay, so this enormous spot on Mars is Hellas Planitia, that enormous impact basin that we talked about. Incredibly old, maybe 4.1 billion years old, something like that. And if you can find Hellas Planitia, which is this very obvious spot in the southern hemisphere, then we have this area in here, the Acidus Basin, and then Syrtis Major is right in here, and Jezero Crater, where we began our journey, which is where the Perseverance rover will be heading very soon. That is situated right about in here. Right about in here. Very cool, as that loads in. There we go. Jezero Crater. Fantastic. Well, on that note, oh, we have a message from OpenSpace themselves looking at the volumetric Milky Way. We could do that. I'm in no rush. And you don't have anything to do either. You can't go out of your house, so we could do that. Cool. Bree says, I really love this presentation. Fantastic. Thanks so much. That's fantastic. I had fun. Thank you for joining me. If you're noticing that flying by, that's the one planet whose moon orbits I forgot to turn off, and I'm not sure what that is. Yeah, so in OpenSpace, this is the version 15.1 beta, or 0.151 beta, and they have a new volumetric Milky Way, and it's quite beautiful. We've only really just touched the surface of what OpenSpace can do. It's a very powerful visualization tool, and one that I definitely recommend you check out. It's very, very cool. All right, so you can see as we're zooming out of the solar system in here and the Milky Way comes into view, quite spectacular, and a great place for us to bring into view for you to send you on your way. So thank you so much for joining us. Remember that you should come visit the Intuitive Planetarium at the U.S. Space and Rocket Center as soon as we reopen. And you should stay safe in the meantime. And also remember that science never stops, not at the U.S. Space and Rocket Center or anywhere else for that matter. My name is David Weigel. Have a good night. Thank you so much.